Now let's look at set notation and understand a little bit more about that. So the first symbol that we're going to see is the element symbol. So it looks like an elongated E. So this elongated E means is an element of. And when we cross it out, it means is not an element of. So this represents that statement and that represents that statement. So if we have a set A that is numbers 1, 2, 3 all the way up to 10, then 3 is an element of A. So we can write it like this. This statement shows that 3 is an element of A, meaning 3 is a number that you would find in the set A. However, 12 is a number that you will not find in the from 1 up to 10. Therefore, 12 is not an element of A. And this is how you would write it. You would have your elongated E and then it's crossed out there. Then the second symbol is the subset symbol. So when we have a symbol like this, it means is a subset of. And when it's crossed out, it means is not a subset of. So what is a subset? A subset is a set within another set. So let's look at an example here. If you have the set P representing numbers 1, 2, 3, 4, 5, and set Q having 2, 3, 4, 5, and R having 5, 6, 7, what do we realize? For Q, the elements 2, 3, 5 are all found in the set P, meaning set Q is a smaller set that is actually found within set P, because everything in Q is inside P. So I can write Q is an element of P. And then if I look at the set R, I'll have 5, 6, 7. So for that set now, 5, 6, 7, I'll realize that some of the elements in this set are not found in set P. For example, 6 and 7. And so R is not a subset of P. The next thing is this small letter n. The small letter n means number of elements in a set. So for example, if I have this set X, which is equal to 2, 5, 9, the number of elements in there, I can count them. 1, 2, 3. So number of elements in X is equal to 3. This means that the set X has 3 elements. Note, I do not put curly brackets here because this 3 does not represent an element, but it represents numbers of elements. So no curly brackets there. Now, the universal set. Now, there are two main symbols used to represent the universal set, and these are the symbols here. So this represents the universal set. So the universal set is a set that contains all sets and elements in a particular question. So if you have a question in the exam, the universal set contains all the elements and all the sets that pertain to that question. So it's the set of everything that pertains to that particular question. And so if we have an example here, this is how you would show it on what is known as a Venn diagram. The universal set would be a rectangle and the other sets would be inside, right? So you've got your set A with the elements 1, 2, 3 and your set B with the element 3. And then you've got 5, 6. 5 and 6 are not inside set A, they are not inside set B, but they're inside the universal set. So the universal set will contain the elements 1, 2, 3, 4, 5, 6. And as you can see, 1, 2, 3, 4, 5, 6. This is everything within that particular presentation there. Now, when you've got an A and a little prime here, this means complement of set A. Complement of set A means what is not inside set A. What is inside the universal set but is not inside set A. So you're looking for what is outside set A. So if you look at this diagram here, what is inside set A is 1, 2, 4. So this is A. But then what is outside set A is 3, 5, 7. So A complement is 3, 5, 7. That's your A complement. Now, union. This symbol here represents union. right? Union means you're joining two sets into one bigger set that contains all the elements in the two sets that you have combined. So if I have set A with the elements 2, 3, 5, and set B with the elements 1, 2, 8, 9, A union B means I'm going to take everything in A and everything in B, and then I join it together. Now this is what I get: 1, 2, 3, 4, 5, 1, 2, 3, 5, 8, 9. Now notice I did not repeat the ones that appeared in both sets. I only wrote it once. So you've got 2 that appears in both sets. You only write it once. And then I put them in order: 1, 2, 3, 5, 8, 9. 1, 2, 3, 5, 8, 9. So I still put the numbers in order of size. That's A union B. Then this symbol means intersection, right? It means what's found in one set that is also found in the other set. So if I have a set X with 1, 2, 3, 4, 5 and a set Y with 2, 4, 6, 8, I realize that 2 is found in both sets and 4 is found in both sets. So A intersect Y is 2 and 4. These are the two numbers that are found in both sets. Now, an empty set. An empty set has got nothing in it. So you can just draw curly brackets with nothing inside, or you can draw a circle and then you strike it out. This shows an empty set. An infinite set now is a set that has no end. It's got an unlimited or infinite number of elements. So if I have a set like this one, 1, 2, 3, and then there's 3 dots, the 3 dots shows that it's going to go on and on and on for until it reaches infinity. And so that's an infinite set.